So we have some basic differentiation rules. Let's take those rules and put them to use. So a couple of things, I guess one of the big ideas that we're going to look at with calculus is being able to find the rate of change of a curve any place on that curve. And for that matter, we're going to be writing equations for the lines that are tangent to the curve. So here we have an equation, 2x squared minus 4x plus 1. It's quadratic, it's a parabola. We could find the vertex, we could graph it, axis of symmetry, x-intercepts, all that good stuff. But I don't care about all that good stuff for this problem. What I care about is finding the equation of a line that is tangent to that parabola at x equals 1. All right, so visually, what are we looking at? Well, we have a curve, a parabola, and then we are looking for a line tangent to it. Pretend that that's tangent. We want the equation. To write a equation for a line that's tangent to a curve, we need to know the slope, and we need to know a point on the line. So slope of the tangent line, you better be thinking, find the derivative. So right now, pause the video and find y prime. You should have gotten 4x, we bring the exponent down and multiply. Exponent decreases by 1 minus 4. So 4x minus 4 is our derivative. I want to evaluate that at x equals 1. So y prime evaluated at 1 is going to be 4 times 1 minus 4 is 0. So the tangent has a slope of 0, which means what? Well, that means that it's a horizontal line. And where is the tangent line horizontal? At the vertex. Ladies and gentlemen, we now have another way to find the vertex of a quadratic. We can take the derivative and set it equal to 0. But I'm getting off task here. That's not what we're actually trying to find. We're trying to find this equation. So the other piece that I need to do is I need a point. I have the slope. Now I need a point. And the way we get the point is we plug our x into y. So y of 1. 2 minus 4 plus 1 is negative 1. So that means the point 1 comma negative 1 is where the tangent line meets the curve, and that line has a slope of 0. So normally I would be doing y plus 1 equals 0, the slope times x minus 1, using point slope form, and I distribute collect like terms. But what I end up with is just y equals negative 1, also known as a horizontal line. And we know that this guy right here, since the slope of that tangent is 0, this is the vertex. Just a little fun ditty for you to think about. Next example. I want an equation for the line normal to the curve at x equals 1. Okay, so equation for the line normal, what does that mean? Well, a normal line, so let me draw that curve again. And we found out in the last problem, this curve, x equals 1 is actually the vertex. We found that the point where that tangent meets was 1, negative 1. The normal line at x equals 1 will be perpendicular to the tangent. And how are slopes of lines and something perpendicular to them related? The slope will be the opposite reciprocal. So remember, our derivative was 4x minus 4. Our derivative evaluated at 1 was 0. This was the slope of tangent. But we don't want the slope of the tangent. We want the slope of the normal. So that will be, we'll call it m, opposite of 1 over 0, well, that's undefined. And that matches with what we would expect because our tangent was horizontal. That means our normal has to be vertical. The equation of this vertical line is x equals 1. Again, if I had a slope, if this was a horizontal line or any other line besides a vertical, I would be using my point slope form. To get the equation of that vertical line. The thing to remember, the thing that you might be a little rusty with, is this part right here. When we're finding the normal, the slope will always be the opposite reciprocal of the tangent line. So this is where I leave you. You have a couple examples now of what we can do with the derivative.